Right, so the first thing that we're going to look at is the Bernoulli principles in soil. Now, before that, let's look at Bernoulli's principle. So Bernoulli's principle is saying that the total head, right, the total head possessed by, let's say, a fluid, total head possessed by a fluid is given by the elevation head plus the pressure head plus the velocity head. Now, what does this mean? So the elevation head. So let's take this image for instance. Let's say we have a table, then we have a tube filled with water. So in this case, the total head for in this case, now let's call it case one, case two, right? In this case, we are considering water is no flow way, right? And so the total head is equal to the pressure head, which is the column of water in the what in the tube, right? Because the water is not flowing. This is in case two, the pressure head is as a result of that is the total head is as a result of the pressure head, the column of fluid. This is the point B, the column of fluid above that point plus the elevation head. So the distance from our reference day to the point that we are considering, that is easy. In some situation where the fluid is moving, then we are going to have the component of what? Velocity head, right? Because if the fluid is moving, the fluid is going to move with a certain velocity. Are you okay? And so we are saying that head is the mechanical energy per unit weight. Now, a tube capped filled with water resting on a table has a HP for the pressure head. So the pressure, I've explained what the pressure head. If the tube is raised up a distance hz, the head increased by az, the elevation head or potential head. Elevation head is measured relative to a datum. So you need to know a datum. Now, if water flows through the tube with a velocity v, there will be another component of the head. So the total energy by a fluid the total energy by the fluid is what we call the total head. Total head. So the energy possessed by a fluid in a system is what we call the total head. And it has three components: the pressure head, the elevation head, and the velocity head. Right? Now in soil, we know that there are small pore spaces between the particles of soil. And so fluid moves slowly. Fluid moves slowly in soil. They are very, very slow. So when a fluid is moving through a soil, it moves with a velocity which is far, far less than the velocity of fluid or water in the soil is less than what 1 centimeters per second square. And so because it's very slow, in this concept that we are going to look at, that's one dimensional flow, we are going to see that the velocity will approximate to zero. And so if we are doing any analysis in soil regarding total head, then we are going to consider the pressure head, the elevation head, then this will go to zero because we are saying that the velocity of the fluid in the soil, in fluid, I'm talking about water, is very what? Very small. And so the total head will be equal to the pressure head plus what? The elevation head. Now let me explain. The pressure head, the pressure head is what? The height of water in the tube. You get it? Then the elevation head is the distance from your reference point. So distance from reference point or D2 to your point of interest. So let's take note. Now, our pressure head, now we know that pore water pressure. Let's make some analysis here. We know that pore water pressure is equal to the unit weight of water times the height, right? And so the pressure head is, if I want H to be the subject, then my pressure head is simply equal to the pore water pressure over the unit weight of water. So we need to note this. Are you okay? So the equation that we'll be working with, the equation that we'll be working with for fluid moving through soil will be given by the pressure head plus the elevation head. And there's our Bernoulli's equation. Now if I have two different points, let's say I have this system that contains soil, right? And this system that contains, so this is soil, this whole thing is soil. So assuming this is my soil, then I connect water to it at this end. Then I let water comes out at this end. And I connect a piezometer here, another piezometer here. The head at this point and the head at this point. Under normal circumstance, HTA to be equal to HTB if things ideal conditions, but from Bernoulli's equation. Now, if they are not equal, that is, it's not equal to this, then there is something what we call a loss. Because under, if things are ideal, the head recorded at the beginning of the flow will be equal to the head recorded at the end of the flow. If they are not equal, it means that there is a component of it that has been lost. And that is